All right, all right, all right. I realized that my audio was off. I'm so sorry. So, good morning, good afternoon, good evening, everybody. This is Dr. O, greeting you from the land of Texas and United States. I don't know where you are now. I'd like to have a little greeting from you there. Say hi on the chat, and let me know if the audio and video are coming out okay before I proceed. Would you guys give me a little feedback on the chat? Hopefully, you're not driving or flying or operating a machine. You are just a little bit relaxed, and hopefully, you can connect and say something on the chat. All right, from Dallas. Yeah, that's awesome. That's awesome. We're not too far. I'm actually here in Northeast Texas, and so very nice. Snuggle Audio Works. Hello from St. Louis. Yeah, thank you guys for connecting. That's terrific. I was saying that part of this year's plans, and Lane, thank you from Huntsville, Utah. I know where that is. Yeah, I used to work in one of the university campus of Utah not too long ago, teaching engineering over there at the south part of the state. So anyhow, I wanted to say that part of my plans this year, with all of you guys that have some connection with my content and me, I want to be able to provide a live event like this one every month, and I will be also recording some live material for you guys that you can hopefully use and give me some feedback on. I got lots of tools that I've been using over the years, and I came across this idea. Why not share the very same tools that I use for my practice as a consultant and teacher with my audience, my friends who are in the same field here. And so, thank you guys for coming on board this morning. For however long you can stay, it's going to be approximately an hour long program this morning. But of course, anyone else who is not present will be able to replay this live streaming today. So, are you guys doing good this morning? Yeah, thanks for taking a little time to come on board and join me for this event. And thank you for setting apart that time in your agenda to be able to do that. I know we're all busy, so hopefully this Saturday we're going to get some benefits out of this conversation. All right, so without further ado, whoever's going to join us is going to join us. We'll go on. And what we got here is, in the days we live, there is so many tools out there that people from all walks of life who are in technology are coming out with. Some tools are well-tested tools. Other tools are still being tested in the process. So hopefully what I'm going to share with you this morning, if you're not familiar with them, you're going to find them useful. If you already have some familiarity with them, you're going to find that these are the industry standard tools that are being used for a lot of the design, modeling, and testing designs before they go into production, whether that's a mechanical, electromechanical, electronic system, control system, or whatever. These are the tools that are being used today. And so we both use it for industry practice and for training and educational purposes. So here I have a bundle of those tools. These are not all the tools that I use, but the ones that I use the most are listed in here. And they're good for any kind of work around the realm of what you will call mechatronics, really, automation, electronics, computer controls, and more. And so that's all mechatronics, which is kind of an emerging theme in engineering. If you don't know what mechatronics is, I'm sure you probably have heard mechatronics and you might even know what that is. But just for our conversation here, mechatronics is defined as the combination of the classical engineering and technical disciplines of electrical, mechanical, computer and control systems. And so this is kind of an emerging theme in industry and in academia, to marry all these various kinds of technologies and make a new science, if you will, that we call that mechatronics. So, anyways, the tools we're talking about here are tools that are being used for mechatronic system design of all sorts. And so the first one is Multisim. And Multisim is a product by a company that actually is based out here in Texas, National Instruments. And they have a variety of flavors around this product, Multisim. They have free licenses. They also have a cloud base. They also have a desktop product. And of course, you can either subscribe in the cloud or buy yourself a license of this product. You may want to go the route of education, because usually education gets good discounts, and try to get that product if you ever want to buy the license, so that you don't have to pay the full price. If you were going to be using this for industrial applications, they might charge you the full price of the license, but you can still use a demo product that you can extend up to 45 days, or you can buy a educational license, which I think runs around 30 or so dollars. I'll get you more information on that. So that's Multisim. The other one is called Tinkercad. This is actually a product of AutoCAD, the big company that produces software for mechanical and other design. They have actually extended a lot of their usage and product to other areas, like SolidWorks and AutoCAD are part of the competing companies in terms of software design. And they have both gone beyond just the mechanical, classical, traditional design. And now they have introduced other features to their software. So Tinkercad is a baby of AutoCAD. And I plan on giving you a little demo, guys, this morning, not just a talk, but a little demo, so that you guys can use it. And whenever I build any new design product, video using these tools, I can pass that information to you. You can replicate, and if you find that useful, you can always use my templates as a way to get started. But again, Tinkercad has within itself the ability to do coding, and that is, you could do a lot with Arduino, which is a very popular platform for microcontrollers, microprocessor design. And you also have the ability to do mechanical design, like 3D design. And of course, the one that we're going to be focusing on is the electronics aspect of Tinkercad. All right, so that's Tinkercad, a second second tool in my list that I use for my practice and for my academic job with engineering and technical students. And then for digital design and microprocessor design, there's a couple of pieces of software that I use. One is called Vivado. The company that produces that is called Xilinx. I do not know where the company is based out. It might be an American company, perhaps, but they produce this software called Vivado. And the idea with Vivado and Quartus, Quartus actually is a product of Altera, and Altera is a product of Intel, and they also produce this ModelSim. So all of these software on the third line here are what's called FPGA HDL software, which stands for Programmable Gate Array Hardware Description Language, right? Programmable Gate Array Hardware Description Language. And so here's what's happening. In the old days, when I went to school, and that might be the case for you too, when I went to school, we did a lot of digital logic design, computer logic design. In fact, we built some, computer-like devices. It was all hardware, right? It was all integrated circuit. The classical AND or NAT, XORs, and multiplexer decoders and all that. It was all manually done by hand. In other words, you have to put the ICs or integrated circuits on a proto board and connect that via wires, right? Well, that has changed, And the new arena for digital logic design is FPGA HDL. And so, again, these are the two pieces of software that I recommend because I use them in my own practice to create projects and to help students create their own projects. I know a couple of you have just joined our meeting here. Will you tell us where you're coming from? The last two of you that have just joined us, thank you for joining us this morning. Okay, this is Dr. O, and we got a number of friends from around the globe here. And I'd like to hear you give me a little message on the chat so that I know you're listening well, and the audio and the video is coming well. We're discussing these engineering software tools that we can all use for the enhancement of our work, whether that's in industry or training, academia, or whatever the case might be. So give me a little message on the chat. The rest of you that are joining us, okay? All right, so FPGA was the last thing that we were discussing, and we'll see what if we can do a little demo. Our time is always limited, but I'll do my best to give you a demo on each of these pieces. And then the last one is the latest software for automation and controls. If you have done automation and controls, you know that the traditional way to do PLC's automation and control is by using the most common programming language, and that's ladder logic, right? We know that. Have any one of you, just by chance, used ladder logic in your whereabouts? Send me a little message in the chat. Yes, I have used ladder logic. And so there is a variety of companies that produce controllers, and of course, the common way to program these controllers have been using ladder logic. There's a couple of competing industries or companies in the area of automation and controls. And you want to guess who those companies are? You can send a little message in the chat. You want to guess who those competing companies are, which are the big competitors in automation and controls PLCs? You probably know that. I'm guessing you do know. All right, so anyhow, we'll take a look to this CCW software. That it's one of the popular ones. There's also a movement in the arena of open source PLC. So there's a company that had just came out, and they call themselves Open PLC. Now there's also another product along the same line, which is Factory IO. And so anyway, this could be a lot that we're talking about. In fact, we have just mentioned here at least 2, 4, 6, 8, around 9 different products that you can use based on your circumstances and needs. And so that is the line of products that we're talking about, the ones that I've used in the past, and the ones that I recommend because they're very mature in where they are. Okay. All right. So let's look a little more. This might be information that you guys want to make note of. Again, this video is going to be published, and you're going to have this information to review, share it with your friend if you like, and if you are okay so far, we got another 40 minutes or so. Could you give me a thumbs up to say, yeah, this thing makes sense, or doesn't make sense, so that we can change the theme? Give me a thumbs up on the live stream screen there. Just send me a thumbs up and see if the message coming across, the information is making sense. I want to make sure that we're both on the same page. All right. Nice. I got a thumbs up. Thank you for that thumbs up. That's good. That's good. I'm glad. I'm glad that's the idea, that you guys can find this useful. Great. Thank you so much for the feedback. And so here we have on the second slide the four groups of products we're talking about. And I'm going to dwell a little bit so you can take note of the sites where you can get, free licenses of these products. And if you do work for a company, then you may have to pay for these products as a licensed product for commercial productions. But again, for personal use, you can get around and find a license that you actually can use for your own productions. Thank you for the thumbs up. Appreciate it. All right. So what I'm going to do in the next few minutes is give you a short demo on the use of these products. And we're probably going to start with MultiSim, and then we'll cross over to CCW, and then we'll do Tinkercad, and if we have time, we'll do FPGA HDL. So that sounds great. All right, let me go ahead and minimize this. Give me a second. And I want to start out with MultiSim. Okay, I'm going to minimize this for you. And I'm going to move this over. Okay. So making the switch here to MultiSim. See if I can stretch this window a little more. All right. And once again, thanks guys for your patience. My live streaming software wasn't working too well, so I had to work a way around this. And so here is a design in MultiSim. Let me just start by the first one. So I'm gonna do the first one here. So here is a little design, and this is using MultiSim. This is actually the desktop version of MultiSim. Okay, desktop version of MultiSim. And what we got here is just a little small design that consists of a pilot light, right, with a drain resistor, and basically you can power up and unpower that light with that switch, as you can see. Okay, but before we do that, we're going to have to run the simulation. So I'm going to run the simulation. All right, simulation is running, and there is the light energized. There's the light de-energized, right? And we have actually a voltmeter across that resistor, which is a voltage divider, that is checking out the voltage. So this is what you could do. They actually have also 3D parts and components that you can use besides just schematic, right? So this is an example of the use of Tinkercad. Let me do the second example with the inverter, right? So this is a logic gate. Let me arrange this. So represent a logic gate, which is an inverter. And if we recall from basic digital logic gate, an inverter takes an input signal and outputs the opposite of that signal, right? So here we have an inverter that we can run and simulate, right? When the inverter has a 1 at the input, it provides a 0 at the output, right? So whenever the input is true, the output is false, right? And whenever the output is false, I'm sorry, the input is false, the output is true. So that's a design for an inverter, a digital logic inverter. Nonetheless, okay, so that's that one. All right. Again, I'm going to be working on maybe send you guys, creation of these designs. It takes a little bit of creation. I'm just giving you a demo on the actual operation. Okay, so here's another digital logic gate. This happens to be the OR gate. If you recall the truth table for an OR gate has 2 or more inputs. And the idea is any of the inputs of an OR gate has to be true so that the output is true, right? Other words, if the inputs are false, the outputs will be false. So here is a representation or design for a OR gate, and I can make input A high, right? And the output is high. I can make input B high, and the output is high, or I can make them both high, and the output is still high, right? So that's a design for a simulation and test of an OR gate, right? So that will be the OR gate using multisim. All right, and lastly, we're going to do an AND gate. This is an AND gate for the test of an AND gate. We recall from the truth table essentially that all of the inputs have to be high before the output is high, right, for an AND gate. So let's run this one. In this case, our inputs A and B for this particular gate, 7408, are low. Therefore, the output is low. If I make input A high, the output is still low because the condition is that all inputs have to be high, right, on an AND gate in order to be able to have a high output. So this is a little bit of a rundown of digital logic gates using multisim, right? So that is the use of multisim for basic digital logic gate design. And again, why do we use these tools? Well, part of the reason to use these tools is because it will facilitate the process of actually developing a product in real life. In the old days, when we didn't have these tools, we used to burn a lot of components before we got a product out, tested and prototyped. Nowadays, you can design, simulate, test on the virtual workbench, if you will, and once you know that the system is going to work, then you go ahead and implement it. That's actually a common practice pretty much across all technical industries. All right, so far so good, guys. So this is multisim. I'm going to go ahead and shut down multisim here. All right. Give me a little bit of heads up on multisim. A little bit of heads up on multisim. Okay. Yeah, another Texan, 1995. Thanks for showing up. Thanks for joining us. I appreciate that. Thank you guys for staying tuned in. We're doing pretty good. So far, we talked about the various software tools, and we also have introduced one of those software tools, which is multisim. I am going to go ahead and start the second package here in a minute. If you guys don't have any questions. Sorry about my pet. My son's dog, she's barking, so I'm sorry if you guys can hear that. That happens these days when you're doing remote work. So, okay. So here I have, this is the one of the prime automation and control software. It's called Connected Component Workbench, CCW, right? CCW. Okay, that sounds right. Texas, Tijuana. Yeah. I think that happens. All right, thank you guys for staying to it. So we just talked about multisim as a software virtual design tool to be able to produce a design before we go and build that system and prototype it and produce it, right? So now we have here a automation and controls PLC software that is very popular. And part of the reason why it's popular is because there is some competing companies out there. And I'm not going to advertise no company, but there's two significant companies that are the leaders, if you will, in the market. Now, you guys know that there's controls and PLCs of all sorts and brands, right? There's a lot of those. But two of the major producers of software and hardware for that industry are Rockwell, Allen-Bradley, and Siemens, right? American and German companies. And so I'm showing you here the product, which is called Connected Component Workbench, abbreviated is CCW. And this product actually is free of charge for personal use. And you may have to get the professional license. But to be honest with you, I actually have done consulting projects in automation and controls. And I've used this very same software, which, by the way, this is a secret for all of us, is a software that is free of charge. So you guys, after this session, can go, if you have not done it, create a account at the Rockwell.com site, Allen Bradley Rockwell.com site, and find the CCW software and download the software if you're interested in learning about automation and controls PLC programming. All right, so this is a big one. There's actually two more that I use, but this is the one that I use the most. A lot of my projects are built out with this. Now, the beautiful part about this software is that this is the real deal. In other words, whenever I design, test, and simulate a project on this software, the same design is ready for production. In other words, all I have to do is download these onto a piece of hardware, whatever my compatible hardware is, and I already have a product, even from the early stage of design, test, simulate. I already have a product which I can just download. So anyhow, here is this product. As I mentioned before, one of the popular programming languages for automation controls PLC has been Ladder Logic, right? Ladder Logic has been one of the main programming languages. And here we have an example of a Ladder Logic program, okay? Thank you guys for tuning in. And thanks for those of you that for some reason cannot stay. And thanks for those of you that are actually replaying this live stream today, because I know not everybody had a chance to come on board. So anyways, I am looking here at the Ladder Logic program for a particular application that I have here. Excuse me. And I'm going to run this project. And this particular software has a built-in hardware simulator. That's awesome, because again, in the old days, all I could do was to test my software and hope that it will work based on virtualization. Now, today, I can actually pass on or download this software onto my simulator, which is a hardware-based simulator. Where is the simulator? And I can test my project. Give me a second here. I'm trying to see where my, oh, here it is. I have to move it over. So here's my simulator. You guys can see it. So that means I am testing a design, and I can potentially send that design to a 3D simulator that looks a lot like the actual hardware, okay? So if you're not too familiar with automation and controls, don't worry about it. I'm just giving you kind of a demonstration. And again, part of my promise this year is that I'll be live streaming some of these events and I'll be producing for you some content, at least on a weekly basis, on the use of these tools and what kind of things you can do with these tools. But what you're seeing here is a ladder logic program that consists of, imagine that this is the coding for a machine on a production manufacturing site. And so on the left-hand side, we got all the inputs, and that will be sensors and transducers. And on the right-hand side, that is the output, which could be pilot lights, alarms, motors, actuators of some sort, right? So I have here exactly a way to monitor and control this. And if I run my micro hardware simulator, what is going to happen is I can see the action of the inputs and outputs on this controller, right? Even without having to download that onto an actual real hardware. So this is a very powerful tool. Once again, one that I use for my own project. And because I don't do large scale projects, I'm good with the free license. You guys can also get a free license of CCW, right? So the first round represent the start and stop ladder logic for a motor. That's motor 0 or output 0. The second one actually consists of another output, which is enabled by two inputs, which they mimic the action of the AND gate. In other words, these two inputs have to be on before this turns on. And then lastly, we have on the third part a simulation for an output that takes the condition of the exclusive OR in digital logic. Again, I might be talking to you a lot of jargon here because you may not be familiar with, but at the same time, just stay with me. I'm just giving you a demo of the power behind these free tools that you can actually download to learn automation and controls. And by the way, if you do a search on PLC programmer, even now, you're going to find that there is literally hundreds of companies and jobs for someone who masters the art of PLC programming. So we're talking about a very highly sought after beneficial skill. PLC automation controls programmers, they make significant, I mean, and I don't want to exaggerate here, but the low end of a PLC programming job could be 60 and the high end could be 120 a year. So you have a range of really potential nice income if you ever become a competent PLC programmer. And that's what we're talking about here. This is all about PLC programming. What is the relevance of this? Well, almost every machine today will have a type of controller, whether that's an Allen Bradley or Siemens controller or some other servo controller, but somehow you got to be able to do some programming to the machine. And it's most likely that the programming required for that machine to be controlled by a controller, it's going to be some form of ladder logic programming. So anyhow, let's go ahead and run this. I'm going to go ahead and I'm going to download this onto the controller. Okay. And it's going to take about a minute. All right, let's just hope build started. So I'm actually downloading this program that I demonstrated to you onto this controller, right? So we can test it out. That's the idea. And I hope we don't have a breakdown here. I hope everything goes well. So I'm waiting on the program to be downloaded onto the controller itself. So we can go ahead and run it. Okay. And yeah, so nice. We got the program built. You see that? It's compiling, no errors. Okay, that's awesome. And I'm waiting to have another good message in here. All right, so it looks like we have no errors in here. Everything was built correctly. So I am going to go ahead and see if we can start running that. Okay, build successful. So this is what you normally do, right? You have a program and then you have to download that onto the controller. Once succeeded. All right, and let's see, we place this in run mode. Okay. Okay, so I am going to do a download one more time. Okay, so this usually takes a little bit like a minute or so to get that download taken care of. So that's what we're doing, downloading the program. And once it's downloaded, then I'll give you a demo on running this particular application, which is the ladder logic or code to run a motor with a PLC controller, right? That's what we're going after. We're running a motor with a PLC controller. All right. And of course, I'm running a number of applications on my laptop, and hopefully everything's going to be good once we get it to the end. Yeah, I need a super powerful computer to run so many things here, right? So I'm due for a brand new laptop, and I think that's going to be something they're going to be pursuing soon here. But this is normal. Whenever you're doing PLC ladder logic programming, the process of converting that code, that ladder logic code into binary, right? So that the computer or controller can understand, it's quite a process. So it may take a couple of minutes, and especially as we are having here to run multiple applications. So thanks for your patience on that. All right, once my clock is done, we shall be able to run the application. You'll see both the ladder logic enhanced or illuminated, and you also will see the actual output of the controller. There we go, at work here in just a few seconds. So thank you guys for your patience. Okay. All right, we're doing pretty good. There are 3 languages that you actually can program in the CCW software, and that's actually a huge advancement on software for PLC controls. The reason being is because the industry for controls have set 5 industry standard programming languages. And so this company, Rockwell, that produces CCW, Connected Component Workbench, has set the software so you can do programming in 3 different languages. That's awesome. So you can say that this software is trilingual, right? Speaks 3 languages. And so the 3 languages that you can program CCW in is in ladder logic, function block, and a structured text. Once again, talking about competent PLC programmers, if you can program in 1 language like ladder logic, you're good. If you can program in 2 languages, you're better. If you can program in 3 languages, you're much better. If you can do 4 or 5 languages, you're great. Any company looking for automation controls PLC programmers, will pick you up as a PLC programmer because you have domain over multiple languages. And you'll say, why is it that we have so many multiple languages? Why don't we just have English, right? American. Well, because we need those other languages to do business with, right? Like we have with, Spanish, Italian, French, Portuguese, and Cantonese, and all those languages. We got to have, in the realm of industrial applications, multiple languages to be able to interact with various kinds of software applications and companies and so on and so forth. So anyway, it's taking a little bit. Let's see. I think, okay, might have a little issue, but let's just see here. So there's our ladder, and there is our program. It says ready. So we're having a little bit of an issue. And again, it's probably computer power that we're dealing here with. So you can see that my inputs are being recognized correctly, right? All the inputs are being recognized correctly. But I have a little delay here on the actual output. And I don't know what's happening. I'm trying to manage multiple screens in here to see if I see any error. All right, so thanks for your patience, guys. This is what it is. And so anyways, you can see here. Oh, here we go. You see that? So now our system is working. You see that? So our system is exactly doing what it's supposed to do. Okay, so you see that? Our outputs are working. Okay, now I'm missing one more thing here. And what I'm missing is that my ladder logic up on top should also be illuminated. The inputs and the output should be on as I turn. Okay, oh, there we go. Let's see. So here we go. You see that? So we had an error here. And so I'm sorry that we had that error. I just want to show you real quick here. So you can see here that the ladder portion of our program is working. I wanted to show you a couple more before we move on. And our time is getting short here. But whew, it looks like my software collapsed. Okay, so my software is collapsing. And I'm going to have to let it go. Okay. Sorry, I'm going to have to close the software. So it's collapsing, but you got the point, right? Sadly, I couldn't show you the other two programming environments, which would have been structured text and function block. But you got an idea, and hopefully that idea will give you an idea to become a PLC programmer of some sort. And so I am going to see. Are you still guys with me? It looks like we might have a glitch on the system. And if we have a glitch on the system, all right, it looks like this might be the end of our live streaming. So okay. Are you still with me? Okay, we're almost at the end of our presentation. We're almost at the end. And I only had one more thing to show you here. I'm going to end this process so we can close our presentation. Okay. So I'm going to have to close the program. I don't want to delay anything else here. Okay. I'm going to close this program. Okay. Thank you guys for your patience. These are real things that happen, right, in presentations like these. We're not perfect, right? That's part of the issue. So I'm going to close out this one, and I'm going to do a less item to present. Let's see. I already had it, and so let me. Okay, so the last one I'm going to talk to you. It's a wonderful tool called Tinkercad. I already talked to you about that. And with Tinkercad, there's a lot that you can do. Tinkercad is free for educators. You might be able to get an account, but it's another wonderful tool that you can use for the design of software, right, and all of that, to be able to do electromechanical software-based programming, design, testing, modeling. So I am going to pull up here an example. All right, and it's a simple example, right, of a very simple system. It really is a power source, a relay, a switch, and a lamp, right? That sounds like a flashlight, right? So imagine that you're producing the greatest and latest flashlight. All right, well, you can use Tinkercad to model your project. And so this is my prototype for that. Okay, so that's my prototype. And you got all these tools to build this stuff here with Tinkercad. That's awesome. And let's go ahead and run it. You have to run the simulation. And now I can test my product, right? So that's the greatest and latest flashlight, which uses a 5-volt relay as a way to enable the output, which is the light in the case of this flashlight, right? So that's one product, right? Let's do another one. Here's another one. For those of you that like to do breadboarding prototype, same idea, right? We got a design here. We're going to run it. And now I have a switch here that turns on that system on and off, right? So this is using Tinkercad Electronics. Tinkercad Electronics, very powerful tool. You could do just about anything. I'm gonna give you a word of caution. It's not perfect. I have found some, weaknesses in the software, but for what it is, free and 3D code-based software, it's pretty good. So I use it for a number of different training and projects that I've done in the past. Okay, so that's one product. Here is another one, a very simple design. Now, what I'm introducing on this little demo here is the ability to check current, right? So here's a circuit that consists of 2 batteries, that's 2 power supplies, along with a resistor, along with an indicating diode, along with a switch. So once I run this, I can do the same, right? I can check for the circuit. And I have an ammeter connected that is doing exactly that. How cool that is. Very cool. Okay. And then lastly, we have a design. Will you promise me, guys, you're not going to break the property, intellectual property rights here? This is actually an actual prototype of a product that I'm working on. This is an actual prototype. Yes, Texas Iguana. I'm gonna add that. Yep. Thank you for that. So this is an actual prototype. I have a prototype for a problem that I have encountered that I'm solving. And so here is an actual project application. Um, on my product that I'm prototyping, I need to be able to sense moisture or water leaking. And I have three sensors in here, right? These are three sensors that will detect moisture, water leakage. They could be just sensors of any type. They could be pressure sensors, flow sensors, level sensors. And I want those sensors to send me a signal over to an actuator. That actuator could be anything, could be a motor, could be a light, could be an alarm. And so this is an actual design for a product that I'm actually myself designing for a problem that I have encountered out there. And I even hope to be able to either outsource the part creations, and my job could possibly work business to business relationship, or even build a system myself and sell them out. So I'm using Tinkercad, a free software tool design, to prototype my product, right? And you guys can do the same. It's exactly for that purpose. So in this particular case, if I run the application, our time is going quick here. What I'm going to have is I want any of the three sensors to send a signal to the actuator, right? So if this sensor senses water or humidity, I want that sensor to turn on the actuator and send me a signal to a pilot line, right? And it's doing it. That's that sensor, or it could be this sensor. This sensor can be located at various spots in the location or building where humidity or liquid levels are perceived. And this sensor could be sending a signal over to a place to be able to actuate or run an actuator or some kind of lights and alarms. All right, so that is my list demo. I want to thank you guys for coming on board today for this exciting live streaming on engineering software tools. Give me less heads up, telling me this was valuable. I will continue to produce at least a monthly live stream for you guys, and we'll continue to produce on a weekly basis more software design solutions for your own practice. I bless you all. May the Lord bless you and keep you. May his face shine upon you and be well with you and your family. Okay. Thank you so much. And we will be seeing you on another presentation in the future. Keep an eye on announcements on Udemy, because the next one will be maybe just a pre-recorded training of some sort using these tools. Okay. Thank you so much. We'll be seeing you next time. God bless all. Bye-bye.